All right, let's talk about something we see literally every day, but probably don't think about too much. We're going to pull back the curtain on two of the most important safety features in your home, this invisible net that's working right now to keep you safe. And it all starts with this. You've seen it a million times on the plugs for your big appliances, your computer, your washing machine. But what is the deal with that third pin? Why do some plugs have it and others don't? Well, the answer is actually a really clever piece of safety engineering. Okay, so to get to the bottom of that third pin, we've got to talk about a really important safety idea called earthing. The best way to think about it? It's like an emergency drain pipe for electricity, just sitting there waiting for something to go wrong. Here's a simple way to picture it. Imagine electricity is like water flowing through pipes. Well, earthing is like an emergency overflow drain. Its only job is to give any dangerous electrical spills a safe place to go so they don't go through you. So let's say something goes wrong inside an appliance and the metal case suddenly becomes live with electricity. That earthing system kicks in and gives all that dangerous energy a super easy escape route straight into the ground, protecting you from a nasty electric shock. So how does this electrical drain pipe actually work in a real emergency? Well, it all comes down to a fundamental law of physics. It's about giving electricity an offer it just can't refuse. And that leads to a really good question, right? If there's a problem and you touch that faulty appliance, you're a path to the ground. The earth wire is also a path to the ground. So why does the electricity choose the wire instead of you? Well, it's because electricity is kind of lazy. It always takes the easiest route. Let's compare the two options that stray electricity has. It could try to travel through your body, or it could go down that dedicated earth wire. And as you're about to see, the difference between these two paths is, well, it's huge. The human body, electrically speaking, puts up a pretty good fight. It has a high resistance, somewhere around 1,000 ohms. You can think of that like a tiny, bumpy, clogged up dirt road for electricity. It's a tough journey. But now, look at this. A proper copper earth wire has almost no resistance at all. We're talking about just 1 ohm. That's not a dirt road. That is a massive 8-lane, freshly paved superhighway with zero traffic. And that right there is the whole secret. When electricity has the choice between the 1,000-ohm obstacle course through your body or the 1-ohm superhighway through the earth wire, it's not even a contest. The current is going to pour down that easy path, bypassing you completely. So let's see what that means in the real world. Imagine an appliance without earthing. A wire comes loose, the metal case is now live. You come along and touch it. Suddenly your body is the only way for that electricity to get to the ground. The result? A very serious, possibly fatal electric shock. Now, let's run that exact same scenario, but this time the appliance is earthed. The second that loose wire touches the metal case, a gigantic surge of current rushes down that super low resistance earth wire. That huge surge is so big that it instantly blows the fuse or trips the circuit breaker in your home, cutting the power completely. The danger is gone before you even knew it was there. Okay, that makes sense, right? But how does this amazing safety system actually get from the ground all the way to your microwave? Well, that brings us right back to our friend, the third pin. And this is so important to understand. This isn't some happy accident. Manufacturers deliberately design their appliances this way. That metal body is connected to the earth wire right out of the box on purpose. You know, if you could slice open that thick power cord, you'd find 3 separate wires inside. There's the live wire bringing power in, the neutral wire taking it back out, and then there's that third wire. Usually it's green and yellow. That's our hero, the earth wire. And that green and yellow wire is physically bolted or screwed directly onto the metal frame of the appliance. This makes sure that the entire metal shell, everything you might touch, is constantly and securely connected to that safety superhighway back to the ground. It's like an invisible shield. Okay, so that's earthing. But you've probably heard another word thrown around that sounds pretty similar, grounding. Now, people often use them to mean the same thing, but they're actually two different jobs that work together as a team. This chart lays it out perfectly. Just look at the purpose. Earthing, like we've been talking about, is all about protecting people from a faulty appliance. Grounding, on the other hand, is about keeping the entire electrical system safe and stable. Look, if you take away just one thing from this section, let it be this. Earthing is for people, grounding is for the system. It's a really simple way to keep them straight. Okay, so earthing protects people. We got that. But why does the whole system need to be connected to the ground? I mean, what does grounding actually do for the power grid? Well, think about it like this. The actual Earth, the ground beneath our feet, that's like the ultimate zero point. It's a stable, universal reference. By connecting the whole power system to it, we're giving it a reliable 0 volts anchor. Without that, voltages could drift around and become totally unpredictable and dangerous. And hooking the system up to the ground does a bunch of really crucial things. It keeps the voltage steady, it gives the electricity a reliable path to get back where it came from, and this is a big one, it's what allows those circuit breakers and fuses to react super fast when a fault happens. So you see, they're not the same thing, but they're a team. Earthing is there to protect you directly, but it can only do its job because grounding is there in the background, keeping the entire system stable and safe. They need each other to work. That little third pin is an amazing piece of simple, life-saving engineering that we just take for granted. And it really makes you think, doesn't it? What other invisible systems like this are out there, quietly protecting us every single day? They're all around us, if you just know where to look.